If the quest for age reversal were a game show, we'd finally be in the lightning round. For decades, scientists have chipped away at the mystery of aging, teasing out molecular culprits like telomere shortening, cellular senescence, and epigenetic drift. But recently, things have shifted from understanding aging to actually trying to reverse it, one biomarker at a time. The million-dollar question is no longer, why do we age? But rather, how close are we to rolling back the clock, and can we do it without turning into a sci-fi cautionary tale? Spoiler alert, we're closer than ever. Not to the immortality promised in comic books, but to real, measurable reversal of key biological aging markers. Think of it less as a magical transformation and more like cellular restoration, like trading in a clunky Windows 95 operating system for a sleek, quiet upgrade that still remembers your passwords. Let's start with telomeres, the tiny caps at the ends of chromosomes that keep your DNA from unraveling like a fraying sweater. Every time your cells divide, these telomeres get shorter, until eventually the cell either dies or enters senescence. Shorter telomeres are associated with everything from cardiovascular disease to cognitive decline, which makes them a prime target for age reversal therapies. Several interventions have shown early promise in maintaining or even lengthening telomeres, most famously the 2019 TRIM trial, thymus regeneration, immunorestoration, and insulin mitigation. This small study involved growth hormone, DHEA, and metformin in a cocktail aimed at immune system rejuvenation, and not only did participants show telomere lengthening, but also a reduction in epigenetic age by over 2 years after just 1 year of treatment. Which brings us to the holy grail of age tracking: epigenetic clocks. These clocks, based on patterns of DNA methylation, offer a more nuanced view of biological aging than telomeres alone. They've become the molecular equivalent of a biometric passport, telling you not just how long you've lived, but how hard your life has pushed your cells. In recent years, we've seen studies suggesting that interventions like diet, stress reduction, and supplementation can actually rewind these clocks. The Fahey study mentioned above used the Horvath clock to show measurable reversal. More recently, a 2021 clinical trial by Kara Fitzgerald and colleagues found that a multimodal lifestyle intervention, rich in methylation-supportive foods, moderate exercise, sleep optimization, and stress reduction, reversed biological age by 3.23 years in just 8 weeks. No experimental drugs. Just salad, steps, and serenity. Then there's the matter of cellular senescence, the zombie-like state that cells enter when they're damaged but refuse to die. Senescent cells secrete inflammatory factors, degrade surrounding tissues, and basically behave like biologically toxic roommates. Clearing them out, or preventing them from accumulating, is a hot area of research. Enter senolytics, a class of compounds that selectively destroy senescent cells. In animal models, these drugs have extended health span and improved function across multiple organ systems. Clinical trials in humans are still in early phases, but promising signals are emerging. For example, dasatinib and quercetin, a senolytic combo tested in small trials, improved physical function and reduced markers of senescence in older adults with chronic diseases. Other compounds like physatin, a plant-derived flavonoid, are being explored for their ability to act as gentler, over-the-counter senolytics. Gene therapy is also sneaking into the spotlight. In mouse models, partial cellular reprogramming using Yamanaka factors, a set of 4 transcription factors that can revert cells to a more youthful state, has extended lifespan and reversed signs of aging in multiple tissues. While this technology is nowhere near human-ready, companies like Altos Labs and Rejuvenate Bio are betting big on the idea that we can selectively reprogram cells in vivo to reset their aging clocks, without accidentally turning people into stem cell soup. So how close are we, really, to reversing aging? The honest answer: biologically, we're inching into the early innings. Clinically, we've seen legitimate, reproducible age reversal of some key markers, especially epigenetic age and telomere length, in small but controlled trials. These aren't cures for aging, but they're strong hints that cellular youth isn't entirely lost with time. What's missing? Larger trials, more diverse populations, and long-term outcome data. Reversing a biomarker is great, but what matters most is whether people live longer, healthier lives as a result. We also need to understand the risks. Pushing cells too hard toward youthful states could increase cancer risk or destabilize normal cellular controls. The future will likely involve a careful balancing act, rejuvenation without runaway replication. But make no mistake, the age reversal revolution is underway. Telomeres can be lengthened. Senescent cells can be cleared. Methylation clocks can be rolled back. We may not have bottled youth just yet, but for the first time in history, we're holding a few drops and the vial's getting fuller.